Okay, I believe my screen is visible. Oh, can anyone confirm?
Yes, sir.
Okay, thank you. So just to give an recap, what yesterday we discussed, right? So yesterday we spoke about the smart grid, the connectivity, right? And we saw the layers, how the data flow starts from the field devices and it will go up to the cloud layer. And also we spoke about the SCADA system, how the SCADA system will analyze the data what the field devices has acquired. And that is one thing. Hold on. Okay. And then we also got to know like the data flows from the bottom to top and the command will flow from the top to bottom. Okay. Then also we spoke about the backbone of the control, operational control, that is the SCADA, right? So SCADA, what why we are using for the real time monitoring, the remote control access, and the alarm and the events, the collection of the historical data, and the so on. And also we saw how the field devices are connected to the master station, so that is through the cable. And also we spoke about the how we can able to utilize the wireless technology and the 5Gs, and how the connectivity will be established from the field devices to the master station, right? And that is how we acquire the data. And also we spoke about how the analog signal, that is this signal which is acquired in the field devices will be converted to digital signals, that is zeros and ones. Then it will be the transmitted to the uh, master control room by using the transmitting media, right? That is one thing we saw, and this is very high level of how the data will flow. And we also spoke about three important protocols, that is DNP3 and IEC 61850, and also the Modbus. And we also spoke about the ISO model, that is the seven layer of model in the networking as well as in the communication system, right? So we spoke about individual layers, how the physical layer works, the data link, the network, the transport, and the complete application layer will work, right? And this was the very important topic as a foundational topic, right? And in depth we saw like what is the advantage and what is the disadvantage of DNP3. In the similar fashion, we talked about IEC 61850 in the substation architecture, and also the Modbus. So this is what we spoke about yesterday in the brief, right? And today we will talk about you know a little further. And yesterday I was telling we will talk about the AWS components today, right? So like I made a little changes. So today we will not completely talk about the AWS, but only the few the offerings or else like the services what we will be talking. And I will be doing the complete session on only the AWS component so that it will be easy for you guys to do the assignments, right? So in this specific module it will be only selected AWS services what I will be teaching or I will be just telling you about, right? And the in depth in the couple of the modules I will be covering, right? So now, we spoke about the SCADA system yesterday, right? So how the SCADA system will acquire the data, how the data will be processed within the SCADA system by using various algorithm, right? So now, once we process the data, so the process data will be migrated to the cloud. So basically, so what we are doing is, so the SCADA system will be reactive and the cloud intelligence will be proactive. That is, SCADA system will give the input to the cloud algorithms, and cloud algorithms or AI and ML models will do the predictive analysis and give it the intelligence. So it is kind of the what is happening to the what will happen. It is all about the predicting the next event, right? So this is a very much important one. So it's all about the edge to cloud architecture, right? So you can able to see in a very high level. So yesterday I was mentioning about the edge routers, right? So edge routers, so this is it is also known as the gateway, and in the simple terms we call it as an routers, edge routers. All the substation, all the control stations will have this gateway. It could be a router. A router can be a Cisco model, the HP, Aruba. So it could be an any model, right? So basically, it should be able to support these specific protocols. And this data, this gateway, which has been utilized to send the data to the cloud, so this will be sending the data to the cloud by using the streaming layer. This is very important in a modern architecture. If you are designing any system, right? If you are designing any streaming system, this streaming layer will be very very important, right? So I will be explaining this in the depth, right? And so moving on to the cloud layer, we will be utilizing the time series database. Yesterday we were, in generally we were talking about the database and how the database can be horizontally expanded. For example, if the data is acquired like 5 GB per day, it can be expanded up to the hundreds of TBs, right? And it can be an archived for so many years. That is the good part of the cloud layer, right? Now, so in the edge layer, as I was mentioned, so we will be having the router, and these router will be supporting the gateway protocol like DNP3, IEC 6185, and also the IP, or else like JSON one, right? Yeah, this one. And also the second good part is it will be having the buffering. So let's say we are having so many data coming in, right? So let's say it at a specific time, at a peak, let's say 11 or 12, 12 11 a.m. or 12 p.m., we are having the 1 GB of data coming into the gateway. And so the data link, we may not support that kind of data, right? So we have to store the data. That is called the buffering. Buffering is like we are temporary purpose, we are storing certain data in the cache. So this gateway will be having some the caching. For example, it could be having the 8 GB of RAM or something, the buffering, and then after the buffering, these data will be pushed to the streaming layer, right? And the streaming layer, this is very very important component. That is, we importantly like we have MQTT or else the Kafka. You might have heard about these two very famous the streaming protocols what we have in the modern technology, right? For example, like MQTT is the message queuing telemetry transport, or else the second option what we are having is this is an Apache Kafka. So this is an open source streaming technology what we have, correct? So how this works, so I will be giving a link to these two, okay? MQTT in the depth it will be showing how exactly the packet will be composed, and it will be sending to the cloud. On this session I will just give you in a very high level what exactly these two are, right? So in MQTT, like I have another slide, let me open that first. Yeah, so this is how the MQTT broker is, right? So this is always the publish pub sub model. So if you say like you are designing a smart grid, right? So you have to measure a lot of parameters like sensors. It could be an the breakers, it could be an IEDs, right? So this the streaming layer, if we are using the MQTT broker, so what this broker will be doing is it will collect all the data for the streaming purpose only, and we can able to uh, do the subscription. So these are all called as subscribers, right? And also the cloud service. These are all the subscribers. What this MQTT broker will be doing is based on these parameters what we have collected. So it will be sending the data to the specific subscribers. So this is all about sub pub sub model. This is what we call publishers and subscriber model, right? And this is what the MQTT is all about. And in the similar way, we have the Kafka. So Kafka is an open source, that is an Apache one. So even this, what it will be doing is it will collect all the details of the data, the parameters from the field devices, IEDs, and there will be a device gateway. So we spoke about this, right? This is the router on premises, edge router also we can call it edge routers. So this device will stream the data to the Kafka. So Kafka, what it will be doing is we can able to do the filtering also. So let's say if the certain parameters we don't need it, so we can able to filter out, or else if you need only the specific parameter which needs to be filtered out and sent to the cloud, that way we can able to reduce the data. For example, you can able to see, for example, we have the n number of the devices in the field, right? And it may produce 500 GB of data, for example. So if you are pushing the 500 GB of data to the cloud every day, the cloud storage will exponentially increase, and also the processing of that amount of data may require some time also. It it incurs the cost, correct? So for that, what we can able to do is we can able to do the filtering and send these data to the cloud, and it can be able to reduce to significantly less data. So the Kafka, this is the one of the the streaming service. It is pretty famous now. If you see any of the architecture, like it could be an hybrid architecture, the on premises and the cloud. So the Kafka is the distributed event streaming platform, what we call it as, right? So it is a very high performing data pipeline, the streaming analysis, the integration, and so on. So I request everybody to just have a look into this technology, so it will help you in the future, because all the applications, all the streaming service nowadays are built on this, the Kafka. And if you say like if you don't want to use the Kafka, then we have MQTT. So this is also very famous, the broker, streaming broker, where we can able to utilize this to do the streaming, right? So this is what the streaming layer will be doing. And just a minute. Yeah, yeah. And the second part, how the streaming layer works is, so we don't have to collect the data every time, right? It could be an event driven. Let's say on a specific event, for example, if in the field there will be some fault or some event in the control center, right? So only those data can be fetched to the gateway, and then we can able to send to the stream. And in the streaming we can do the filtering, right? So this is how we can able to fetch the details, right? So this is the streaming layer, and all the data which we have filtered using the streaming layer will be pushed to the cloud layer. In the cloud layer, the very famous the database what we will be using it, TSDB. So this is what we call it. It is the time series database. This is very important one, because all the data what we are fetching from the field devices will have the timestamp, because while doing the analysis we need to know at what specific time this event has been occurred, right? So we are saving this in the time series database. So we have a different database type. So we have we'll talk about the different type of database in the coming AWS series, okay, which I will be teaching. And so we have the RDS, and we have a Dynamo DB, and so on, right? But in this case, we are using the time series one, right? And so this time series database will be having complete information of the data, and then this data will be transferred into the data lake. So in the AWS, coming to the storage part, we will be having the S3, the very famous one. You might be heard about the AWS S3 bucket, right? S3 bucket can able to scale up to 100 of TB, right? And it can able to, at a single object, can able to upload up to 5 TB of data in the S3 bucket. And also we have Redshift, and this is where we call it as in data warehouse. So these are the two important storage. So in S3 we can able to store the any kind of data that is like, so there are three different kind of data what we can able to get it from the, yeah, get it from the on-premises devices, right? From the field devices. Let's say it could be structured data, or else it could be an unstructured data, and the third one is semi-structured data, structured data. So the structured data is where while streaming, right? Streaming the data. So, so the schema has already been defined. It is already have been defined. For example, so structured data will have the device name, device ID, and the timestamp, and the location, and so the substation name, and also that specific the control unit name, and so on. So these are all the columnar devices, and it is structurally formatted, correct? All the data which we are acquiring from the field devices will automatically go into these fields, I mean data fields, right? So this is called in structured data. And why it is used? It is very much easy to do the analysis. So we can able to do the SQL query out of these structured data, and the analysis of these data will be very easy, right? And the second part is the unstructured data. So let's say, for example, we have an SCADA system which is connected to one of the IDE, right? So, so these device, this will produce the random numbers, or else random details, correct? So this is not structured. It will just simply give some ID and some timestamp, which is not as per the standard. So even though this is not as per the standards, these details can able to store it in the database, and this will be classified as an unstructured. So basically when we receive these unstructured data, so we have to clean them. We call it as an ETL process, that is extract, transform, and the load. So this is what we will be doing it. Let's say uh, we have different intelligent equipments all over the the perimeters, or all over the house, and also in the substations or in the power plants, and every these devices are producing some data, correct? And this data is not structured way, so every device can able to give their own outputs, correct? So how do we consolidate that? So what we will be doing is we will put everything in the S3 bucket. So S3 bucket can able to accept the data even though it is structured data, unstructured or semi-structured. And then what we will be doing is we will be cleaning the data. So we will be cleaning the data based on the field devices or categories or sensors, or it could be any of the uh, latest devices type. Correct. So based on our requirement, we will be doing the cleaning of data. Correct. And that is the unstructured data and the semi-structured data. So most of the cases in the smart grid technologies, we always get the semi-structured data. Semi-structured data is the JSON. So is it is in Java script. It is like what is it? So it is a Java based script notation. Okay, so it will be like in this the flower bracket will be open and there will be a certain data which includes the device type, device name, and it is all the key value pair type. And this kind of data, it is known as the semi structured data. And these data can be easily can be queried with some degree of cleaning of the data. Correct. So this is what actually in the scenario, like um, in actual scenario, is what we will be getting it, right? Okay, let me. Okay, okay. Let's let me give an example now. Let's say we have some JSON data which is which is produced by some of the intelligent devices or the sensor in from the field devices, right? This is the JSON data type. And what it will be doing is this JSON data type will be coming to the streaming layer. So let's say we are using the MQTT. So this is the broker. What it will be doing is it will see the filter first. So whether this specific the sensor is allowed to send the data or not. If yes, what are the parameters that needs to be sent? So let's say this the sensor is looking after this voltage, the current and the frequency. Correct. So in the MQTT we can able to filter out to get the parameters of voltage, the current and the frequency only. If we have other set of data, it will be ignored, so that we can able to save some space and also the bandwidth in the substation, right? And then now the MQTT will push the data to the respective database. Before the database, it will be dumped in the S3 bucket, that is the storage cloud storage. And from this storage, as this JSON is then semi-structured data, so we will be cleaning the data by using AWS Glue. Okay, this is the service where we will be using to do the extract, transform, and the load. And from after the cleaning the data, transforming the data, it will be stored in the time series database. So database, right? Yeah. And from the database, this is the database. From the database, we will be utilizing the AI and ML algorithms, like, let me clear this. So till now, anybody has any questions or the doubt on this AWS part, or else like the streaming services, service layer? Anyone has any questions?
Sir, only one MQTT. What is full form, Master?
MQTT. Okay.
Yes.
So basically, it's a message queuing telemetry transport. Message queuing telemetry transport.
Okay, sir.
Okay. And the Kafka, it is the name itself, the Kafka, but it is an open source. It belongs to our Apache. So Apache is a very open source platform. You will get more streaming data cleaning, those kind of technologies, right? Okay. So coming to this application layer, right? So now we have stored our the data here in the time series data. Now we will be using the AI and ML models. Correct. So let's say in AWS technology we have SageMaker. SageMaker. This is the AI and ML. So we have, for example, let's say we have what is it? So there is one called PyTorch and TensorFlow. So this is a very popular open source frameworks. Correct. And also the please make sure that you do some research on this because the assignments will be slightly based on these AI and ML models. Okay, and also we have the scikit-learn, and also we have the Apache, MXNet, and so on. Correct. So these four is what it is very much important for you guys because let's say if you want to simulate these smart grid technology, right? So either you required MATLAB or else like very licensed softwares, correct, but you don't not everybody can able to afford it, correct, but you can able to simulate by using these models, the pie chart, the tensorflow, scikit learn. So these are all very much important and these models are also used in the enterprise industries, right? So make sure that you are familiar with these models, correct. And why these models are used? So these models are used to train the model. One is to, let's say, train. So we already have this data available in the database, correct, right? So we will be training it model and deploy it, deploy the model in the SageMaker. SageMaker is a platform and we can able to choose the what AI and ML model it is required. And third model is to predict. Correct. So this is how we are utilizing the uh, AI and ML model. So if you see there are a lot of AI and ML models available now within the AWS or is in the open source. So you might have heard about LLMs, correct? LLMs. It is large language the models. So it is an open source. So you can able to download these models in your laptop, and you can able to train that model to whatever the desired output you required. For example, you can able to download these models, these models within your laptop. There is certain specification that is needed to download this and the train them, right? So you can directly get these data from the gateway. You can able to simulate by using the Python. Also if you cannot afford hardware, right, so you can able to simply write a script in the Python telling that this is the input which is expecting from the device, and you can able to train the model LLM. And what model will do is it will give the desired output, correct. This is how you can simulate, you can learn how the smart grid technology will work and how you can able to improvise the technology, how you can able to adopt the technologies. So these are all, this is the one of the way. And second thing is, now we already have this data AI and ML model, right? So now we have to have the visual dashboard, correct? Let me clean this out. So don't worry, like I will be showing everything once we are into the AWS software, right? So I will show everything, its look and feel, and how it works, right? I will show you everything, but just understand the concept why we are using these AI and ML model in the smart grid. Okay. Now, so we have the AI and ML models. Now we need to have the dashboard, correct? Because we need to see what is happening in the complete the smart grid, and we need to have the all the parameters displayed in the single pane of glass. How do we do that? Now, so output of this AI and ML will be pushed to the Grafana. So this is one of the visual tool. Okay, the Grafana, or else you might be knowing about the Power BI, correct? So this is the business intelligent visual dashboard. So you can able to use the Grafana or else the Power BI. So if you go into any of the industry, right? So either they use the Grafana or else the Power BI. Correct. So what this will be doing is, so this will give you the entire grid information. Correct. Or else if you are using for an any solar panel or solar installation, these dashboards will give you complete information about the solar panels, solar installation, the cluster of substation, and so on. So this is what we will get as an output. Correct. Now see so from the field devices, that is smart grid, we are taking the data through this gateway. Then we are pushing to the streaming layer, and to the cloud layer. We are saving in the data lake. Then we are moving into the time series database. Then we are using the AI and ML model. From there, we are getting the output, right? Yeah. So one of the assignments probably you will get is based on these technologies, and make sure that you do some research. And this is not only for your curriculum, when you come out of your college, right? So this is what the current industry is adopting. And also the if you see any of the RFPs, right? So this is what the terminology what you will get it, right? So this is how we do the system designing. So anybody has any doubts? Okay, so let's move further. Okay, so this is what we already discussed. So the golden rule of grid architecture, correct? Especially the smart grid architecture. So protection will always remain the local. So the logic, the constraints, the latency, everything, it remains in the on premises. When I say on premises, it could be a substation, it could be an solar installation, or everything. Now only the required data will be pushed to the cloud, where we are doing the analytics and forecasting. Correct. And these forecasting may take some time. It could be in seconds or else minutes, because so we will be having the very huge data, right, which is residing in the database. To process that data, it may take some time. Correct. And also it requires massive amount of compute power. So in the AWS, as in server, we call it as an EC2 instance. So this EC2 instance is nothing but it's an server. So you might be seeing the server in the SCADA system, right? Within the on premises or within the control center, which will be inside the substation, or else like any remote control unit, right? So similar fashion, we have the EC2 instance, we can able to spin up within a minutes, and we can able to use this server to analyze and do the forecasting part, right? So this is how it is, and the golden rule of the smart grid technology is the protection stay local and intelligence move to the cloud. Yeah. And yes, IoT, I will not repeat again. This is the same thing. We have the different field devices, correct? These are all the sensors, it could be an IDs and so on. These are all the smart enough, and these are called as IoTs. Okay. And the very key important here is the security uh, part. Okay, I will just focus on this for now. So let's say, for example, you might ask a question telling that, okay, these devices will be installed in the field, correct? It's in the open field. How are they secure? So physically, yes, we can able to do the fencing and able to protect it. But in terms of digital security, how how it will be secure? The question is, so one of the way to secure these devices, IoT devices, by using the certificate based authentication and identification, right? So for example, if you don't have any security enabled in any specific IoT devices, right? So anybody having the internet connectivity and the LAN connectivity, they can able to simply plug in the LAN cable into this, into specific port, by using a laptop. And what he can able to do is he can able to either fetch the complete information, and also he can able to push the malware into the complete smart grid. And this is what we have to prevent it, correct? So let's say, yeah, so this is what secure certificate based authentication works. Let's say currently, imagine this, the client is our smart devices, smart grid, smart device. Okay. So now, so what it will be doing is, when we install any smart grid, any device within the smart grid, first it will go to the server. The server, it could be in SCADA, or else it can go to the cloud also, just to authenticate. So what it will be doing is, it will say, uh, so uh, so it will communicate to the servers telling that I want to get connected to the system. So the server will have different devices, right? It could be an device 1, device 2, device 3, and so on, correct? So many devices, and this server will have the details of all the devices. And also, if we have connected any database, then the database will be, these devices will have the access to the database also, right? So now, think like you are trying to install a new devices into the system smart grid, and when you try to do it, so it will first ask the server telling that, okay, I want to join to the complete grid, smart grid. So then the what server will do is, server will give his certificate is like an digital ID, you can think like a digital ID. So what it will be, it will be having information like the server name, its ID, and complete information about the server, so that when you have this CA installed in the server, the anybody can authenticate, because the third party or else any attacker can able to install different server, and these connection can be hijacked, right? If you think like it is an attacker, so he can able to get these device onboarding into their server, and from there he can able to push some malicious code to the devices, right? It should not be happen. So what we will be doing is we will first authenticate, and we will do all the necessary security action in the server. Once the device wants to connect to the server, so it will ask, it will present its certificate to the client. Here it is in smart devices, right? What the client will be doing is it will check internally, so whether this certificate which is provided by the server is authenticated, or it is genuine or not, correct? So it will be checking the authenticity of the this certificate. Once it is it checked, then what it will be doing is, again this server will request the CA of the client. Now the client has received the certificate of this server. Now server will ask the certificate of CA. Again, the server wants to authenticate who exactly the client is, correct? Even we have to install the certificate in the field devices, and in the certificate we will mention type what is the type of device, to whom it is registered, and so on. So this is what the information the certificate will be carrying. So once the server has asked the client to provide each certificate, so it will go to that certificate, and it will produce the certificate to the server, right? And now the client has been given the certificate, and also the server has given the certificate. So both of them will validate the each other certificate. once the validate Once the validation of certificate, only the connection will be established between these two, correct? So let's say if something goes wrong, if the server is not able to identify the a certificate which is provided by these field devices, it will never be on board, it will never onboard these devices. So now we are securing our smart grid, correct? Let's say what will happen if we are not enabling any authentication. So anybody with any rogue device, when I say rogue device, it could be an any malicious devices, they can able to simply plug into the smart grid, and he can able to do the spying, or anytime he can able to bring down the grid, correct? It is very much risky. So this is very much important. It is security based authentication, right? The device will get authenticated to the server based on the CA. This is very very key important topic. uh, this is actually implemented in various the host and client. For example, let's say take an example. When you try to connect to any Facebook, correct? Facebook server from your browser. So what when you will type the Facebook, the request go to the server. Server will present its CA to your browser. Browser will have the list of all the certificates, right? And it will check whether the server which is providing this certificate is valid or not. So once it is authenticated, then only the connection will be established. Similar way, your browser will also provide the certificate to the server, so that it will authenticate, okay, this is the good user, and then only the connection will be established. This is what the complete the what do you call the concept is. So in the similar fashion, the field devices and the server will be authenticated, and then the communication will start flowing, right? Yeah. So coming to the end-to-end part, so we saw the sensor. Okay, so what this sensor, let's say it can able to check the voltage spikes, the current, and everything. And then we have the IEDs, and we will be configuring either IEC 6185, the goose, or like DNE. So based on that protocol, the communication will establish from the IED. The data will be moving to the SCADA system, and from the SCADA system, the data will move to the gateway. From the gateway, so we will be utilizing that in the cloud AI. From there, we will be giving the recommendation, or else we will be giving the visual visual dashboard to the management. Correct. This is very high level flow, how the field devices in the smart grid can able to communicate. And this is the data flow, and the command will be from the cloud AI. Correct. Command will then go to the sensor, telling what exactly needs to do, whether it has to break or else. So whatever the command it could be, right? Yeah. So coming to the summary part. So whatever we have learned, correct, the smart devices and also the hybrid model where we are utilizing the OT, IoTs, OTs, right? So these are all the field devices, correct? OT is the operational technology and IT is the information technology. So we are trying to merge these two as in smart grid. So it is like combining both the two to get the latest technology out of that within predicting model. So what we are achieving is here we are achieving the hybrid modeling. We are modernizing the system, and also we get the real time the data, and it's the future proof. So this is what the future uh, grid looks like. Correct. So this is very summary of the convergence of OT and IT. Right. Okay. So this is all about the SCADA system and the integration of the IT and OT. So anybody having any questions?
No, sir.
Okay, so we'll have 5 minutes break, okay, and we'll start with another topic after that. Thank you. Okay, so we'll start with you know new topic now. So can anybody confirm like my video and audio is good, and also I'm sharing the screen. Is my screen visible? Can anybody confirm?
Yes, sir. Yes.
Okay, thank you. Okay, so we spoke about the SCADA system, right? So now we will talk about the automation of the grid, and what are the control strategies we have. So now we almost got to know like the modern power grid. It always rely on the automation, right? And also it relies on the artificial intelligence to take the decision, and it's everything is in the closed loop, right? So it is linked to the reliability, efficiency, and resilience. So it could be not only limited to the hydro or else any of the specific power station. It is widespread across the all the generations, like it could be an solar generation, hydro, and also it could be the bio, and also the nuclear plant, right? It is across all the power generation units. And let's say now, let's talk about you know AFDI, right? So this is what I was talking about, the intelligent grid, where we are trying to integrate everything. It could be this AIF, A, AFDI. We will talk about more about this AFDI, and also we will talk about the DR, that is the demand response, and health of specific devices equilibrium. So we are trying to combine everything, and so this when we combine this, that is what the intelligent grid output is, right? So now we will just focus on this specific area, which is called as AFDI, that is automated fault detection and isolation. So it is also known as FLISR, that is the fault location isolation and the service restoration. So this is also known as that. And this is what the core technology behind the self healing grid. So because we are trying to build an intelligent grid, correct, smart grid, how do we do that? When we say the smart grid, the grid has to identify where exactly the problem is, and it has to remediate, it has to self heal itself. So when we can able to achieve that, then only we can able to call it as an intelligent grid, correct? So let's say, for example, so currently, in the most of the cases, right, it's all about the manual response, correct? So manual response, if something, for example, um, take any of the transmission line, if some trees fell fell on that tree, then somebody has to visit, and you have to, the manually patrolling will be happening. It is all reactive. If something happens, then only we will take the uh, response to that, correct? It's a time consuming, but it is an effective, but it takes some time. So what if we do it is it as an automated way? So that is where AFDI comes into the picture. So it uses the intelligent electronic devices, IEDs. We already spoke about this, correct? What exactly these devices? These are the field devices. So these, we will be utilizing these devices to detect the fault. And when we integrate these devices into the system, we can able to achieve the self-healing system, right? Yeah. And so this is one of the complex the diagram. Usually you might have seen these single line diagrams, what we call, right? So where you can able to see the main substations, the transformers, the feeders, and so it is, and also we you can able to see the control circuits right here, the controllers. So this is one of the example how the SCADA system will give you the output, or else any of the smart grid technology, the dashboard will looks like. And also this is how the electrical BESCOM, or any of the KPTCL, substation single line diagram looks like. So it will have all the components. If you see uh, the transformers, the feeders, and everything. Let's say if something happens in the any specific area, if you see there is an some short circuit here in specific area, right? How do we detect that, and how do we isolate the fault at the earliest, right? So detection is what we need, and we are focusing on that, correct? So before that, yeah, okay. So this is what the flow looks like. First, we have to detect the fault, then we have to localize it, and then we have to isolate, and then restore to the normal. For that, we have the different layers. We should use the sensors, that is, in the general terms, we call it as an eye, correct? Where we are utilizing the like IEDs, the phase meters, the fault indicators, and so on. And to communicate these, the fault or else any of the event within that field devices, we use the communication. So we already spoke about IEC 61850 goose, or like any other communication, the protocols, right? And then we are sending that to the brain. So here we use the rule based AI logics or any of the algorithms to decide what action needs to be done. So once the decision has been taken, so actuators are the physical devices. It could be an reclosers, it could be an circuit breakers. So these actions will be sent to these devices, so they can able to make or break the circuit. Correct. So this is what very high level we will be talking about. So detection, localization, isolation, and the restoration part. Now let's take a scenario. So for example, we have a line. Correct. From so we have the breakers, and so just a minute, I will be back. Yeah. Let's say the something, the tree or any of the object fell on this the line. How do we detect that? The simple way is by using IEDs, as I spoke earlier. So what IEDs will detect? Whenever there will be a fault, obviously there will be an overcurrent. Correct. So there will be a spike in the current. So these devices will detect that one is overcurrent, and second part is obviously the voltage will be dropped because there is an fault, right? So based on these two parameters, what these sensors or IEDs will do is it will create one fault flag. So this is an alert. This will be sending to our SCADA or any control system.
Sir, your voice is muted.
Oh, okay, I'm sorry. I will repeat once again. Okay, so this is one of the scenario. Okay, so it is very common scenarios what we see, right? So we have a line and some object or else the tree fell on this specific line. Then obviously, so there will be two parameters we have to look for. Correct. One is, see these IEDs. What it will sense is it will detect the overcurrent. Obviously, because there is a fault, there will be a very high current, the spike in the amps. Correct. And the second part is obviously there will be a drop in the voltage. Correct. So these two parameters will be picked up from the IEDs. So these are all the IEDs, and what it will do is it will create a flag. Okay. So once this flag has been created, so this information is sent to the SCADA to take the action. Correct. So this is the two parameters. Now, so whenever you send the packets, correct? So what packets will be having that? If you see, if you go back to that, right? So we were talking about IEDs, correct? Here, so these IEDs will be generating this kind of the packets. So these packets will contain the information like, so this is how the packet looks like. So this packet will have the device ID. So every IED will have one ID. So it could be some ID, correct? And also this will have the timestamp. What is the specific time it has been triggered? And second is like what kind of flag? Correct. It has detected the fault. And if we have configured to capture the the waveform oscillograph, right? It will be recorded in this specific payload. Correct. Now this is how the packet looks when it communicate to the SCADA, right? Now moving on to the next. So how we are going to calculate it? So very simple formula we are having, right? So we need to calculate the distance. So this is how the distance. This is the point A. Assume that this is the point A and the point B where we have the fault. Correct. So now it is D is equals to VF by IF and Z line. So D is the distance that is from the substation. This is what our substation is. And so VF, it is the fault voltage magnitude. So what is the voltage at a specific fault time? And this is the current, right? It is then fault current magnitude. And then this is the impedance. So these are all the values we will get it through the device, intelligent devices, what we will get it. So when we have these parameters, then we can easily calculate the distance, and we can able to easily spot where exactly the fault has been occurred, and immediate action will be taken. So let's say, do we need to send the personnel to the specific location? The answer would be no. Why? Because so based on the calculation which has been done in the SCADA, so SCADA will automatically open the circuits. If you see, this is the switch number 1, switch number 2, switch number 3, and switch number 4. Correct. So this is where the fault has been occurred. The SCADA system will automatically isolate this part. So you don't have to send any personnel to repair that, or just to open the circuit breaker, or and so on. Correct. So this is how the immediate. So it could be in the milliseconds. The action will be in the milliseconds or in the few seconds, right? So this is how we can able to isolate the fault zone identifying. The command is set to the load breaker to open it, and so on, right? Now let's see in the next slide. So now we have identified where exactly the fault has been occurred, and the second, we have isolated the specific fault, and we have to restore it. Correct. So if one line goes out, so we cannot say to the customer or else end user telling that, okay, this has been, there is an outage, you will not get the power for next certain days. You cannot say that. When you are building a reliable system, it has to be continuous supply of the power to the consumers. How do we do that? So if, even though if we have identified and there has been the fault, so we can able to isolate that, and we can able to provide using the alternate feeder, right? So now the alternate feeder will be, even, see, even though this is not supplying, the alternate feeder will continuously supply the power either to the household or else to the factory, right? So everything happens within in seconds or the milliseconds or the seconds, right? Now see the impact. So initially in the legacy or else the older days, we usually go and do the manual braking, and it was time consuming. It could be it could be an hours or else so on. So now when you implement this automatic fault detection, right, so we can able to cut down that duration of isolating and restoration to the minutes from the hours. So that is the major impact what we will be having here, right? So now, so what kind of faults we will be detecting? So right, there are like a lot of type of faults happening. Single line to ground, that is called as SLG, line to line, and double line to ground, and three phase, the high impedance fault. So there are many faults might occur due to the natural calamities or the human error. It could be anything, correct? So if you see the statistics, right, this is what I was talking about, restoration time. So in the traditional restoration manually, it could take some hours, but when you implement AFDI, it is in the milliseconds or else in the minutes. So this is where we are trying to improve it. Correct. So you might ask, okay, that is one of the formula what we had. So do we have other formulas? Yes, there are, like we have a different formulas, like also different method to calculate the impedance, right? So one other way is, okay, I will just write it here. Let me clean this. Other few methods are, okay, so I will write here. So other method is, it's a fault location. So we have the formula called D is equals to divided by IF into X line. This is one of the probably you might already know this, right? So these two parameters VF, this is VF and IF is the fault voltage and current, and X line is the reactance per unit length, correct? And so this is the imaginary complex impedance what we are going to add. When we have these parameters, we can easily calculate the distance. This is one of the method we have, and the other method we have is the protection coordination, that is also called as TTC curves, correct? So in this, what we will calculate is, okay, and A divided by to the power of B minus 1. Okay, so here, the T is the trip time. Okay, and if we want to calculate trip time, right? So we have to get some parameters. So this is the constraint, invariant constraint. Okay, and A and P are the constraints what we are having, and TD is the time dial settings, the multiplier for the shifting curve. So this is very complex one. So you can able to read some research paper on this. So it is very complicated. The way of calculating the trip time. This is one of the method, but the first formula what I was telling, it is kind of easy, and it is most easier way to implement it, right? And that is one thing. And other formula what we are having is, so the restoration. In that we have P total, P current, and P load for the zone A, which needs to be less than P max B. So this is one of the way to calculate, where it is to calculate the thermal limits, and these are all the loads. Okay, This is one of the way. So these are all, like, the complex way to calculate in the trip time, and also to calculate the capacity and load flow. So you don't have to worry about it. So if you are really interested, you can able to do some research on these the ways of calculating that the fault, right? This is one of the ways. So anyone having any doubts on this? Okay. So now, as per your syllabus, like, we have to integrate the parameters and utilize the AI to get the output, correct? That is the objective of your module. It's all about the smart grid, and also integration the smart grid with the cloud, and then utilizing the generative AI to get the insight out of that, right? So now, so how do we blend these three separate you can call it as in parameters or like something like that, correct? So let's say we have the transformer, and we have the circuit breakers, we have the cables and substation equipments, correct? So now we also spoke about the AI analytical engines initially, correct? So what exactly we are feeding here? So this is called as data funnel, correct? It is just an imaginary one. Okay, so what we are feeding here is, so inside the transformer we will be having the oil level indication, correct? So what we can able to get is like level, and also we get the temperature of the that oil, right? And the various other parameters, like the acoustics and vibration sensors. Why this is very much important? Because so if the transformer is vibrating too much, then there is a chances it may break, correct? So for that reason we have to just collect the acoustics and also the vibration sensor details to this. And yes, the temperature reading, it is not only for the transformer. We can able to get the temperature readings for the LT panels, HT panels, and we can also get it for the capacitor banks, and so on. And also we can able to get the temperature reading for the sensor also, right? And can able to we have to get the details of the thermal aging, the load cycle, and so on. And the partial discharge measurements, the weather information, weather data. It could be an the humid level. It could be heat, the temperature of the environment, heat, the moisture, and so on. So when we collect these details, correct? So these details can be funneled. When I say the funneled, everything will be put it in the this AI analytical engine, correct? So now when we say the output of this, what will be the output? So we can able to see how the transformer heating prediction will be based on, for example, these data will be collected over the year, 1 year of duration, or else 6 months. And we say on a specific duration, like on the Monday and Friday, there is a trend telling that this transformer is getting heated up due to the overload, correct? So also we can able to say, okay, in the morning 11 to evening 3 p.m., the temperature of this specific transformer device is very high. So it is predicting. So we can able to say for the next 6 months, this will be the trend. So the transformer on this specific time duration, it will be overheated, and for that, to reduce that, we have to take necessary action. So such as we can able to increase the cooling on this specific time duration, let's say 11 a.m. to 3 p.m., increase the cooling of this specific transformer, so that the temperature is maintained below the threshold. So that is one way of doing it, right? And the second is the circuit breaker. So there in the inside the circuit breaker, so when you break break and make the circuit breakers, there are there will be certain contacts, it will wear out, correct? So we we had collected the data for the last 1 year in the interval of the months, correct? And we also have how many times the circuit has been open and the closed, right? Based on this, we can able to say, so these circuit breaker need the maintenance after 6 months, so that we are predicting the next 6 months we need to change certain variables inside the circuit breaker. Always we have to do the maintenance. So here if you observe, we are not waiting for the circuit breaker to fail, correct? We are proactively telling that, or else we are proactively scheduling the maintenance of this specific breaker. So when we know that exactly on the 6th month we have to do the maintenance, we proactively we can able to ask the substation to take the downtime, inform the customer, or inform the industry in the 1 2 or 3 days before, telling that there will be an the downtime, so that the customer or industry can able to plan accordingly, instead of suddenly breaking certain feeder, and this might affect the productivity, and also this might affect the consumers, right? So for that reason, what we are doing is we are doing the predictive analysis here, right? That is one thing. And so the third critical part is the cable. So most of the, if you see, if you ask any of the electrical, the maintenance person, right? So the main important the fault happening is because of the cable isolation. So insulation aging. Sorry, insulation aging. Sometimes the cable which is laid inside the trench, correct, inside the earth, so we will be laying the cable within the trench, or else inside the earth, correct? So after certain time, or some because of some environment, the weather, due to the rain and the sun, so these the isolation, the insulation will be damaged. Because of that, there will be leakage in the current, and there could be no fault occurring, right? So now, before this happens, what we will be doing is we will be feeding the data of this specific cable. For example, we are laying the HT cable from the transformer to the HT panel, and also to HT panel to the LT panel for the distribution, correct? So there has been couple of runs. It could be in 2 or 3 run of cable which will be running from the transformer to HT panel, correct? So we are taking the note of this. So we are feeding the system, telling that when it was laid, the date of the cable laying, and also the make of the cable, make of the cable. It is like who has manufactured this cable and all the parameters related to the cable. For example, what is it? Is this cable is having the armored cable, or it is just an unarmored cable? So when it comes to the armored cable, it has the very higher level of insulations, correct? So these kind of data we will be putting in the database for the analytics. When we have this, so we can able to say, okay, after 5 years or after 10 years, we have to do the inspection of the cable insulations, right? So the system will tell the uh, substation manager or the maintenance person, telling that okay, this specific HT cable which has been laid from the transformer to the HT panel, right, it has to take the maintenance part. So that is one thing. And coming to the equipment part, correct? So even in the similar fashion, what we will be doing is, so the substation might having different components, correct? So based on these inputs, we can able to give the health scoring of this specific substation equipments. So everything, it is no now we don't have any manual calculation, and everything will be done using the AI analytic engine. So all the data what we have collected earlier, it will be processed using this analytical engine, right? So now, so we got to know that the AI will be doing everything. So this process will be occurring in the cloud. We already spoke about that in the earlier slides, right? So now it is very much in depth about the AI and ML models, specifically for the machine learning techniques, right? So if you see here, we have a different technique. This is very, very important. So make sure that you do little research on this, because the assignments, and not only the assignments, when it comes to the real-time implementation, right? This is what we will be implementing in the real time. Let's say, coming to the type of machine learnings, right? So we have AI toolbox. One is supervised machine learning. Just a minute. Okay. So coming to the type of machine learnings, one is supervised machine learning. So so this is one of the type where we use this to predict the failure. Okay, and the other one is the unsupervised machine learning. So in the next class, like I will go in the depth what exactly the supervisor machine learning is, what are the algorithms what we will be using inside this machine supervisory machine learning is, so that you will get to know more how exactly inside this supervisory machine learning models work when we feed the data, when we feed the data of the transformer or else any of the LT or HT panel, right? So it will predict how it will predict. There are certain algorithms which will be embedded inside this machine learning, the models, so that will be used, right? So to do the failure prediction, we always use the supervisory machine learning model, right? And if you want to do the anomaly detection, so anomaly detection is something like if there is any activities, malicious activities, if you want to detect that, let's say if somebody wants to somebody is trying to get access to the control circuit, or somebody is switching off and on a specific control circuit within that HT panel or LT panel. It could be any of the distribution boards, right? So those kind of anomaly detection, so for that we are using the supervised machine learning. So for failure detection we are using supervised machine learning, and for anomaly detection we are utilizing the supervisor machine learning. Now, coming to the deep learning, this is very complex topic. So this is also known as the neural network learning. So what this will be used is the image and waveform analysis. Let's say we have certain outputs, correct, and you want to do the analysis on this output on the specific controller or specific sensor and devices, right? How do we do that? Because these data is like the real time, correct. And also the data is the massive data. When I say the massive, it could be a very large set of data. So how do you analyze it? So you need very the complex the model to analyze this waveform, right? So for that we use the deep learning. So the deep learning is very the critical, and this is one of the widely implemented the models, ML models, in the industries, where we use these to not only to analyze the waveform, we use these to analyze the PDF format, having research data sets, or if you want to solve any complex mathematical equations, right? So we always use the deep learning one, correct. And so reinforcement learning, other one, this is we used to do the maintenance scheduling. So I was talking about this transformer, the maintenance, the panel maintenance, and the cable and so on, right? How do we do that? So to do that, the best model what we can able to use it is the reinforcement learning, right? So reinforcement learning always uses used for the maintenance scheduling, right? This is one thing. Now, so now we have the failure detection, and also we have anomaly detection, the waveform analysis, and the maintenance. So now if you want to forecast this as a time series, right? So we use the time series forecast model, where this model will be analyzing all the time series events, correct, all the events, and this will be continuously monitoring this, continuously analyzing this time series. And then what it will be doing is it will create one forecast for the next the month, or next 6 months or 1 year. Based on this, so we can able to predict something, or else we can able to say, okay, the demand is high on the specific duration of the month, or else we are predicting that that specific month will have very high demand, therefore we have to increase the generation or else decrease the generation based on the forecast what we get it, right? So what is the impact? So when we have these the toolkits, right? So we are reducing the unplanned outages, right? Everything will be planned. So when we have this unplanned outages, so the customer can easily plan their the production, or else plan their day accordingly, right? Instead of suddenly breaking the feeder, and the customer will not be able to access to the power. So this is what we will be having. And so also we can able to do the asset lifespan management. So we know, so when the transformer is installed, when we need to do the maintenance of the specific transformer based on the parameters what we have analyzed, right? So we can easily can able to replace or the maintenance of those the devices within the substations, right? And also the lower opex. Opex is the operational cost. So when you know specifically when exactly the maintenance needs to be done. For example, let's say consider the legacy one. Currently, what the substation will do is substation will have the one time chart, right? So in that time chart, they will simply mention the transformer maintenance is required after 6 months and HT panel maintenance required after 10 months. So like that. So this is just an tentative timings what they have, but to support this they don't have any data, no data, correct? This is just a periodic maintenance. So you have to spend some money on this. Even though transformer is working fine, still you have to do the maintenance every 6 months, right? It is not efficient. So if you know the transformer, when the age and when exactly the transformer need maintenance, we can able to cut down some cost, right? So this is all about the lower operating cost, and obviously so we are increasing the safety of the grid, right? So this is how we can able to utilize the machine learning techniques. So I will go in the depth in the coming classes. Don't worry about this, just understand which machine learning models we are using on the specific use case, right? Now, so everything we call it as a data pipeline, correct? So if you see, everything is on the data pipeline. So data ingestion is nothing but fetching the data, correct? And then we are normalizing it, and we are using the machine learning to do the validation and the training in the real time, and we will get the maintenance alert, right? This is how the machine learning model will be utilized. And when we do the small project, right, in the end, so these are all the models which will be utilized in the AWS. So in the AWS, what we will be doing is, so we will configure one field device, or a sensor we will configure. This will be in the smart grid. Then we will configure the gateway in the AWS, and we will store that in the storage. This data, the field device data will be stored in the AWS storage, that we will use the S3. And after S3 we will clean the data by using ETL process, that is AWS glue, right? And then we will store that data in a database. From the database we will pull the data to the AWS machine learning mechanism, and then from the AWS machine learning we will create one dashboard, and this is AWS dashboard. From there we will send the notification to the user, right? So this is how, as per your syllabus, what we are doing is we are configuring the smart grid. We are integrating this smart grid to the cloud, and we are utilizing the the latest machine learning, AI and ML models, and then we are doing the notifications. So this is what a real time scenario will be. And so if you feel like it will be little overwhelmed because you don't know the AWS, right, don't worry. So once actual your syllabus is covered, so I will be walking you all through this software, the AWS one, and I will configure all the required services, and I will explain in the similar fashion when it comes to your the assignments, you will have the different scenarios where you have to create and choose the different design patterns. You have to choose the different ML, AI, and ML. So it's up to you. How do you do the assignments, right? Yeah. So this is one thing, and yeah, for now, let's stop here. So anybody having any questions? So we'll wait for 2 more minutes, okay? Then we'll start. So yes, we'll start, okay? So I was thinking, let me introduce this AWS, okay, to you. Uday and Sneha, like, have you heard about AWS, and are you familiar with this, technology? Anyone?
Sir, I'm don't know, sir. First time I will.
First time, huh? Okay, no
Yes,
issues.
yes.
Sneha,
Mine is also first time, sir.
first time, huh? Okay.
Yes, sir.
After learning MATLAB for years, Flex,
Sorry,
I know, sir, but I don't know.
Uday, your voice
Flex
is
to
breaking.
MATLAB, so
Okay, how the? Hmm. So,
yes.
but the latest, if you see industrially, MATLAB, ಮತ್ತೆ Simulink, so they don't use actually, ಅಲ್ವಾ?
Sir.
Okay, no problem. I will just introduce this AWS, okay? ಏನಕ್ಕೆ AWS ಅಂತ ಹೇಳಿದ್ರೆ, ಸೊ ಇಫ್ ಯು ಗೋ ಅಕ್ರಾಸ್ ಆಲ್ ಅಂತ ಹೇಳಿದ್ರೆ ಯಾವುದೇ ಇಂಡಸ್ಟ್ರಿ ಆಗಲಿ, ಸೊ ಇವನ್ ಸಬ್ಸ್ಟೇಷನ್ಸ್ ಅಥವಾ ಸ್ಮಾರ್ಟ್ ಗ್ರಿಡ್, ಸೊ ಯುವರ್ ಸಿಲೆಬಸ್ಸಲ್ಲಿ ವಿ ಆಲ್ everything is all cloud integration and AI and ML. So that is what the requirement of your module, correct? So now, so AWS is the cloud service. Okay. So cloud service ಅಂತ ಹೇಳಿದ್ರೆ, so on premises ಅಲ್ಲಿ we will be having some data centers and we will be processing that alva. So in the, let's take an example, you will be having MATLAB and Simulink. So ಅದೇನ್ ಮಾಡುತ್ತೆ, in your local system ಅಲ್ಲಿ you will be installing and doing the MATLAB and Simulink simulations, correct? So in that, in the similar way, but every process will be happening in the AWS. Okay. So if you go to the Google and type the AWS, this is where you will land. And I highly recommend you guys to learn the cloud, any one of the technology. It could be, you know, AWS or else Azure, GCP. ಏನಕ್ಕೆ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಅಂತ ಹೇಳಿದ್ರೆ, ನೆಕ್ಸ್ಟ್ ಕಮಿಂಗ್ ಫ್ಯೂ ಇಯರ್ಸ್ ಅಲ್ಲಿ everything will be either in the AWS or else in the Azure. Okay, and if you see the industrial trend, technology adoption, everywhere you go, it will be in cloud. Huh? So I highly recommend you start, because ನಿಮ್ದು ಅಸೈನ್ಮೆಂಟ್ಸ್ ಕೂಡ AWS ಮೇಲೆ ಇರುತ್ತೆ. It will not be that tough, don't worry. I want you guys to know the technology ಅಷ್ಟೇ. Okay, and the assignments also will be very high level. You don't have to, go in the depth in the AWS services, understand and do all the AI and ML. No. So basically I want you guys to understand the technology. If someone asks whether you know the AWS ಅಂತ ಹೇಳಿದ್ರೆ, you should not say I don't know. So you should say yes, I have a pretty much idea, and you have done your assignments. That is what the objective all about, because I work on a larger scale industry, correct? And I know how the industry is moving, and I know how the things are getting adopted in terms of technology, correct? So please, like everyone, spend some time on understanding what AWS is. So today I will just give you very high level what exactly the AWS, and what are the services we will be using it in the, the practicals. You can call it as in practicals, right? So in this short time, it will be just an introduction, and once you get the time, please visit this website, that is the AWS. And also I highly recommend everybody to create one account. So when you go here, you will ask to create one account, correct? If you go here and you can able to create an account, it's an free of cost, and it will be for the 6 months, okay? And they will provide for for an $100 of AWS credit. So what is the use of this AWS software, correct? And we call it as in software, or you can call it as a technology. So what we will be using in terms of the smart grid, right? So I already logged in. I will just open my account. Okay. Okay, this is my account, and I will share share my screen. Okay. So everyone, please get an account. It's on free of cost, because as I was mentioning earlier, right, in your syllabus, you have the cloud integration as well as AI, right? So everything to do that hands-on, you need to have the AWS account, right? Everybody clear on this? Anyone having the doubt? All clear?
Yes.
Why nobody is responding? So is it very difficult to understand as how it is, or else is it boring? Okay, no issues. So first one, what we will be doing is, because we have field devices, correct? So for that, what we are going to use is the IoT code. Okay, and before that, let me show you the interface. Okay, when you log into your account, the AWS account, it's a cloud based. You don't have to install any software in your local machine. You just have to open the browser. You just have to log in with your credentials only, right? And once you logged into your AWS account, so this is how it looks. And here you can able to see your account details, right? Everything. And if you go here, you will have, if you are developed any of the application, you can able to see, or else if you see the all services, right? So AWS offers the lot of services, right? EC2 instance is the server, and the Lambda. So I I will not be I will not be confusing you all, but just to make sure you are familiar with the interface. So these are all the services. You can able to click any of the specific services on this and you can able to navigate it, correct? So let's focus on our smart grid only now. What we'll do is, so we want uh, IoT, right? So we have the service called IoT core. So this is one of the service sorry one of the service where we will be configuring on-premises device, that is the field device. It could be a sensor and it could be an IEDs, but however we don't have the physical device, correct? Instead of that, we are creating a software, or else we are writing a script. It will mimic the hardware, correct? Because we cannot invest too much money on the hardware, buying that and configuring that, right? And it is not economical also for everyone to procure that. Instead of that, we can able to simply use this AWS IoT. Okay, today is just an introduction, don't worry. We will go in depth once we start doing the hands-on. Okay, just try to understand what exactly the IoT is and how are we going to simulate those, right? And so this is how this service IoT will help us to connect the on-premises devices to the AWS. That is one thing. And I was talking about MQTT protocol, right? So this IoT, the platform, what we are configuring, right? So this will also support the MQTT client. So this is what we will be using it. Okay, and we can also use this for the device locations. And as I said before, we are not using any hardware here, don't worry. And everything, we are trying to create a small Python script which will mimic the actual sensor. Okay, this is all about. And this will be an real-time data injection. This is one of the service what we are going to use it, right? So anyone having any questions on this? No, good. So, and the second, the service what we will be using to do the hands-on, the practicals is IRC green grass. Okay, so similar way. So this is where, if you see here, if you see right, and this is also used for the IoT devices. So when I say IoT devices, for us now it is IEDs and the field devices, the smart devices which are integrated in smart grid, correct? So even this IoT green grass is the on premises. So we have to install the hardware and then the processing will happen locally. Then that will be integrated with AWS cloud. Anyhow, this we will do as in virtual, not the hardware, correct? Right, that is one thing. And to do the streaming service, right? So we have the Kinesis. What this Kinesis will do is, so it will stream the data, correct? So because in the smart grid we will be having thousands of devices, right? And the thousand of devices will be creating the large number of the data, and this data has to be transferred from the on premises, that is from the substation or else any of the control panel, to the cloud. So for that we will be using the AWS Kinesis services. Okay, right. And I was telling, like, we are not using any hardware, correct? So we will be using the software to mimic the hardware. So to write and execute that, we are using the lambda functions. So this is one of the, you know, it is like you can create your small functions. So if you are good at Python, you can just write an Python code, or else you can simply write any one of the code in any of the language, correct. And so in our case we will be writing a simple code uh, to mimic the IEDs, and also we will be sending the data, real-time data, continuous data from the Lambda to our IoT, and from there we are using the AI and ML to process it, correct. Now this is one thing, and to store that we have it, we have in storage. This is an, you think like an storage device, correct. In the AWS we have the, we have called the buckets, right. So here this is just an the provisioning we are making. So all the data which we had received from the on premises, correct, on premises, so those datas will be dumped in the one of the bucket. So we can able to simply create a bucket here. Bucket in the sense it is provisioning of the space to store our data. So it could be an sensor logs and historical data and so on. These data can be stored in this storage that is called as S3 bucket for the very longer duration, for 5 years, 10 years and so on. We'll discuss on that, correct. That is one thing. And this is for the longer time duration storage. And for the shorter duration, so we have the DynamoDB. This is for real time. So the sensor will be sending the data at a real time, correct. So where do we store that real time data? So the real time data will be stored in the DynamoDB. It is called so this is for the semi structured data, JSON data, key value pair. So we will be creating one table here, and all the data which we will be getting from the smart grid, correct, which will be stored in this Dynamo TV, right. Now let's talk about AI and predictive maintenance, right. So we were talking about how we can able to utilize the AI and ML model, correct. So to utilize that we have a service called Amazon SageMaker. So this is all about the data analytics. So we just have to create one the SageMaker. In the inside the SageMaker, we can able to select any specific models what we need. Okay. So based on the information what we got it from our field devices, we are going to analyze by using the SageMaker. Correct. So this is how we can able to select any one of the model. Either it could be a generative AI or classic ML, and we can able to prepare the data and all the pre-trained datas, evaluating and the fine tuning, the build, the train, and then we can able to deploy it, right. So this is very much a key component right now, where we have to utilize the AI model to build, train, and deploy the machine learning models, right. As per your syllabus, you have to do this. So make sure that you spend most of the time understanding what exactly the Sage Maker is. Okay. And to do the forecasting, so we will be using the AWS forecast. So what this will be doing is it will give the forecast. It will give the predictive in the dashboard, so that you can able to see what exactly happening inside the system, right. Okay, so this is what, and also we have the certificate. So I was talking about the certificates, right, CA, where we have to use these certificates to secure our the connections. So we will be using this
the management for the key management services. Okay, that is one thing. And two and other function what we will be using is the step function. So the step function is like you are telling all the components which we discussed, right? The IoT, the SageMaker, and the forecast, or else the Lambda function. So we are going to create one workflow and telling that the system, the AWS system, to how to gather the information from the field devices from the smart grid, and then pull the data, and which IoT or like SageMaker needs to be run at what sequence, right? So we are going to define that in this specific step function, right? And also we have the other service called as Event Bridge. So Event Bridge is to trigger the function. For example, let's say I want to get the information from the field devices every 5 minutes, or else I want the information to be fetched every 1 minute. Okay, so how do we do that? So to do that, we have a function or else the feature called as the event bridge. So we can able to create one simple function here telling that, okay, the software AWS, please trigger the event so that you will get the information from the on-premises devices, right? This is one thing to trigger the events, right? And other one what we will be using is the quick site. So the quick site, this is where this is the graph what we will be using it. So from here we can able to see what is the power consumption and renewable and the power grid, the fault statistics, and everything. So you can configure or else you can create your own ideas here, and you can able to create the dashboard where if you feel like you want to showcase the voltage, you want to showcase the current and so on. So this is the quick set. It will give you the visualization of the data what we have extracted from the on premises, right? So this is what the services we will be using it. And so in couple of days we will start going in the depth what exactly these services are, and how we are going to fit all these services. Okay, so I believe like something is making sense now, correct? So anybody is having any questions how to use this software or log into the system? Any questions? So yesterday I was asking everybody to read the AWS documents, correct? At least get familiar with AWS. Did anyone, try to research on the AWS? Nobody did. Hmm. So I want to know from you guys, like you want to do this kind of real-time examples, or like you want me to do only the theory, and we can able to close this. How you are feeling it? So let's do the practicals or not? Okay. So I have a little more things to cover here. Let me just cover this. Okay, so the last small topic which was left in this session was it is the demand response. Correct. So demand response is like where we are trying to match demand and the supply. So the here what we are trying to achieve is like we are trying to achieve the price based dr. Let's say for any specific time duration where demand increases and we have surplus the power, we can able to provide that within very lower cost. Or else if demand increases and power is very less, and so in that case we can able to pull the power from all the resources. It could be an from the PV cells, or else the hydro bio and so on. So and the smart grids, what it will do is we will be having the real time the prices, the critical peak pricing. So these are all the parameters what we will be having in the demand response, right? So the how this the DR optimization technique will work is, so everything is interconnected, right? So the grid is interconnected and the smart house, which is having this the smart meter. So everything will be talking to each other, and the data will be available based on these data. So the provider will give their the pricing. It could be an on demand pricing. So based on this interconnected, we will be having the more visibility and we can able to serve the customer uh, to meet those demands. Correct. And this is just an how we can able to you know get the actual the proper quality of the power output, and where we are having we use certain the quality controlling devices such as like on-load tap changers. We also have the capacitor bank, static wire, because we have to inject the reactive power into the system, right? Because if not, the power quality will goes down. So we also have the statcom, the smart inverters. So basically we are trying to the get the good quality of power to our customers. And also we wants to maintain the voltage and the frequency, whatever the threshold, it should not go down, right? So that is the main objective of the preserving the equilibrium. So we are trying to maintain the parameters constant in this. And coming to the DER, that is like distributed energy resources. So we have the smart inverters, and also we have these battery banks, and we also have this microgrids. So these grids can able to provide the required the energy wherever it is needed. And to do that, we have the algorithms like fuzzy logic, the MPC, the models, and or else we can able to use the AI driven set tuning, right? So this is like kind of the demand request what we will be using it. So this is all about today's session. So let me know if you guys have any questions, so we can discuss, or else like we can end the today's sessions. Okay. And make sure that you guys just do the research on the AWS for the next class, so that it will be easy for you to consume what I will be teaching for the next classes, right? Okay. So thank you everyone. Have a nice day.